Inside of Visual Studio, I have an employee class defined, and this employee does have a first name property and a method called speak. Now, inside of the program, imagine I'm calling a method called getASpeaker, and getASpeaker returns something that all we know is that it's going to be an object. And I could assign that to a variable of type object. And then the question is, how can I invoke the speak method? Well, of course, if we were sure that this was an employee object, I could type this variable as an employee, and I could coerce the return value of getASpeaker into an employee, and then o.speak would work just fine. But let's imagine that we don't actually know the type of the object that's coming back from getASpeaker. All we can be certain about is that it will have a speak method, in which case we could invoke it using reflection. So I could get the type of this object, and then I could say, get the method called speak on this object and invoke it. Invoke it on the object O. There's no parameters that we expect to send to that method. And just having this in place will actually give us something that works. And if I run the program, we get, hi, my name is Scott. A dynamically typed variable could give us the same effect, but with less code. So let's type this variable as dynamic, get rid of all the reflection code, and just say o.speak. And one thing you'll notice is that the only operations listed here are objects that are available for something that is typed as object. And that is because Visual Studio and the C# compiler, they really don't know anything about O. They're not going to try to infer anything. If I invoke a speak method here and do a build, it's going to succeed, even though we're doing that against something that the compiler really cannot be sure that there's a speak method there. It's all going to happen at runtime. And indeed, if I open up the console window, we can see that it still runs and prints, hi, my name is Scott. And just so you know that I'm not playing any tricks here, let's take a look inside of the directory, and we can see there's a dogs.dll assembly that's in the same directory as my console mode applications executable. And inside of that dogs assembly is a type called dog, and dog is also something that can speak, but my console mode application does not have a reference to this assembly at all. So the compiler, Visual Studio, neither of them know that anything about this assembly or what's inside of it, but we can still load it up and tell a dog to speak. So I could say that the dog type is, first let's load the assembly dynamically, so we're loading up the dogs assembly, and then we're going to get the type called dog. That was the name of the class inside of there. That'll give us back a system.type, and from there what I can do is say, give me a dog using activator.createInstance to create an instance of an object using that type that we found in the assembly. And of course, activator.createInstance returns something that is typed as object. Neither the C# compiler nor Visual Studio, no one knows that this is a dog at the moment, but I can still say dog.speak. And if we do a build and run the application, then we get the woof, which is precisely what we expected a dog to do. And this has been a demonstration of some of the things that you can do with Dynamic. Quite often it can remove typecast from your code, it can remove reflection code where you're using getMember, getMethod, getProperty, and the invoke method to try to set things or get things or invoke behavior. All of those things can be cleaned up with the dynamic keyword. And it shows a little bit of the essence of dynamic programming. That is, I have an object, I know that it should be able to speak, I just want to invoke that without having to jump through hoops and using all this code to put together the right types and the right reflection calls to get that to work. Of course, the question you might be asking is, what happens if I get this wrong? What if I misspell a method name? Well, in that case, you will get not a compiler error, we just build it successfully, but you will get a runtime error. In this case, it's an unhandled exception, a runtime binder exception. A runtime binder is something that is a part of the DLR that tries to facilitate dynamic behavior in a CLR application.